Was meteorite impact the real reason for the formation of continents on Earth? Aren't forces like tidal currents and gravity too weak to move continents? Will this new research overthrow the widely accepted continental drift theory? Yes, the human quest never ends, but this new research can give you some reasonable answers. Welcome back to another video of Theory of Science. There are discoveries made every day that prove the existing theories otherwise. Who knows? Maybe one day we will discover that we are actually aliens. Either way, make sure to subscribe to our channel. Let's get started. The Earth is found to be the only planet that has continents. But what is the mystery that caused these supercontinents to break apart? Now we have new evidence that suggests that meteorite impacts may be the mystery event that played the part. A meteorite is part of spatial matter that falls to the surface of a planet. New research shows that giant meteorite impacts may have formed Earth's continents. Yes, the very reason that is considered to be responsible for the dinosaurs' extinction is also said to be behind the continents' formation. Did you ever notice that the edges of continents thousands of miles apart match up? This proves that Earth's landmass was once concentrated in one big continent. For decades, scientists have proposed theories suggesting that the original continents formed by meteorite impacts, but then they did not have solid evidence to support the claim. Now, Dr. Tim Johnson and a team of researchers from Curtin University in Australia have come up with evidence that meteorite impacts may have formed the Earth's continents. Researchers haven't been entirely sure why Earth is the only planet currently found to possess continents, but this finding may provide some valuable information. The explanation behind the formation of continents has added another dimension. Scientists have now found substantial evidence to justify the theory that giant meteorite impacts were the reason for the formation of the continents. The study found that Earth's continents were formed by gigantic meteorite impacts that happened during the first billion years of the planet's history. These meteorite impacts generated massive energy that led to the formation of oceanic plates, which later developed into continents. This research is very significant as it provides the very first solid evidence that giant meteorite impacts were the process that ultimately formed the continents, similar to those responsible for the extinction of the dinosaurs. The researchers tried to find evidence in zircon crystals in rocks from Western Australia, known as the Pilbara Craton. It is considered the best preserved chunk of crust on the planet, and the zircon crystals are said to contain evidence of ancient meteorite impacts before the continent broke apart. The Pilbara Craton includes some of the Earth's oldest and most well-preserved rocks and fossils. According to NASA, the rocks of the Pilbara Craton in Western Australia are formed between 30.6 billion and 2.8 billion years ago. NASA also notes that the iron-rich rocks here began forming even before there was oxygen in Earth's atmosphere or even life itself. Zircon crystal becomes a critical element of this study because zircons can survive processes like erosion, and they preserve a record of past geological processes, and its significant advantage is that it helps scientists to identify the age of rocks. Zircons are formed by the process of crystallizing magma. Zircons can be called time capsules, as they store the recordings of geological activities. Good job, bud! Under Dr. Tim Johnson's leadership, the team analyzed the patterns in zircons extracted from Pilbara Craton. According to the researchers, the pattern suggests that Pilbara Craton's formation began with the extensive melting of the shallow rocks near the Earth's surface. The deeper we go, the further the melting occurs. With the hitting of the Earth's surface by giant meteorites, the planet's outer shell was melted. This impact released the underlying pressure of the mantle, which could have resulted in the melting, leading to the formation of an oceanic plateau. Does this research overpower other theories such as the continental drift theory? Let's see. The first widely recognized theory was the continental drift theory, which claimed that a part of the crust is capable of horizontal movement around the globe. However, the continental drift theory states that forces such as buoyancy, tidal currents, and gravity may be too weak to move continents. Harry Hess, a geologist, submitted the hypothesis of seafloor spreading, but this new research may overpower his hypothesis as well. The continental drift theory and seafloor spreading hypothesis have supported positive scientific data. Seafloor spreading is a phenomenon that occurs at divergent plate boundaries. As tectonic plates move away from each other, heat from the mantle's convection currents makes the crust more plastic and less dense. The less dense material rises, often forming a mountain or elevated area of the seafloor. Eventually, the crust cracks. I've never trusted the tectonic plates. They're too shifty. The two theories were merged to develop the modern plate tectonic theory. Plate tectonics is a theory that explains the creation of major landforms as a result of Earth's subterranean movements. The theory explains many phenomena, including mountain building events, volcanoes, and even earthquakes. Dr. Johnson explains that if the oceanic plateau gets big enough, it can melt at its base to form granite, which is what the continents are made of. The formation of granite requires both water and energy. Therefore, even though the other rocky planets, as well as our moon, have had past meteorite impacts, they had insufficient or no water by the time the flux of effects weakened. Thus, meteorites impact other planets too, but this phenomenon of continental formation is found to happen only on Earth. So sorry guys, you don't get to experience continental food. The complexity of the world and questions about its evolution remain constant. Will technology one day tackle these questions? Join us in the journey of unveiling the scientific mysteries of the world by subscribing to our channel. Don't forget to ring the bell and hit like. Also, check out our other videos on our YouTube channel.